everyone, and welcome back to our virtual classroom. I'm really excited to talk to you once again. And we are now on week 6 of the course. In the previous weeks, we learned about how earth scientists communicate complex ideas to the general public using basic observational skills and the scientific method to be able to allow us to better understand our dynamic planet. This week, we are going to take all that information, blend it together, and examine and investigate a model. And that model is the unifying theory in earth science. It's called plate tectonics. Now, this idea is a relatively new idea in the world of science. It starts around the 1960s, maybe a little bit beforehand, but it wasn't truly published and better understood until the 60s, and then rapidly understood as new ideas and technology and techniques on both education, such as public outreach and citizen science, and more traditional scientific disciplines like earth science, chemistry, oceanography, and even physics come into play to be able to blend so that way we can better understand what's going on with our planet. So I propose a hypothetical situation for you, or a scenario. Let's say you're teaching maps and geography in your science class. Maps are a wonderful communicator for being able to collaboratively appeal to your learners' sense making. You are able to take a visual representation of a model, in this case, let's say the entire Earth. Actually, I have a map right here, but this is actually a globe. Globes are technically maps. It's how you view them. And by the way, I love talking about plate tectonics because it blends my geography background with my earth science background and allows me just to talk about something I really enjoy. But going back, so a globe is also just a map, same thing as map. It's how you visually represent it. You go from a 2D to more of a 3D approach. But you're talking about the map or the globe to your learners. And you're pointing out all the different countries and the shapes of the continents. But your learner comes to you and asks, teacher, I have a question for you. I wonder, remember, we use the words wonder in this class. I wonder why, when I look at this globe, why are the continents spread so far apart? Well, that's when you can collaboratively work and guide that student, that learner, on how to understand plate tectonics. Plate tectonics is the unifying theory in earth science. It helps explain why our continents have moved away from each other, and that they're getting to the point where they're not only moving away from each other, but they're slowly coming back together to form another supercontinent. But the effects of plate tectonics can be seen all around us. For example, when we look outside our windows out here in Appalachia, the ridges and the mountains and the folds that we see along the road, that's an effect of plate tectonics. But we want to engage our learners. In lecture, we're going to learn about the crust and the density. For an example, a igneous rock such as basalt has a much higher density, is much more commonly found in oceanic crust than, say, a more continental silica-rich sandstone. Because the differences in density, it helps explain why our continents can be found above the water and our deep ocean trenches being found beneath the surface of the waves. We're also going to examine the model of the Earth. What does our Earth look like in cross-section? How does the heat from the mantle help act like a conveyor belt, moving the continents around the planet? For our pedagogy, we want to be able to assess the observation skills of our learners using maps. And we're going to use a variety of different maps. Some are going to be generated with Google Earth. Some are going to be maps that we've taken directly from the literature and use it to tell the story. We're going to look at stories by famous scientists like Marie and her partner, Marie Tharp and her partner, where they investigated the seafloor. We're going to look at evidence put forth by Alfred Wagner, who actually used puzzles as a way to communicate. For right here, we have South America, and then we have Africa. Notice on how they connect and overlap. This tells us at one point, Africa and South America were connected. And that was a line of evidence. We also look at fossil evidence. We also look at climatic evidence and blend them together to help better communicate to our learners that our planet is dynamic. In lab, we're going to use Google Earth to be able to take a look at a few mountain ranges outside of Appalachia. And then we're also going to be able to make a sounding box. We're going to be able to communicate to our learners that there are many different ways to approach different complex science ideas. And the sounding box is a really good one because it blends topography that's being generated through plate tectonics and other parts of the science and engineering diagrams and matrices that I showed you earlier in the course, where you can blend in things like physics, how a sound wave works in relation to the topography found beneath the Earth's oceans. And that will help us better reconstruct what is going on beneath the waves. We can then take a look at what's going on land, put it together to tell a wonderful story of our dynamic blue planet. If you have any questions this week, please reach out. You can reach me out using Zoom. You can get a hold of me using email, or just swing by my office in room 208. Thank you and have an excellent day on planet Earth, and keep learning, my friends.